earlier in previous week. So proceeding further, let's say you have come across in an entire edition. We have stereochemically, I'm just going to elaborate a few aspects in this case. Let's say we have this olefin, cyclohexene. Cyclohexene, if undergo the addition of hydrogen, so hydrogen addition shall be a concerted mechanism. But in that case, because already one hydrogen is there, if a hydrogen, two hydrogen there, so it shall be a not a symmetric center. But if deuterium is added, deuterium with the help of palladium catalyst, then it shall definitely result in the formation of new stereoisomer. Both shall be having both hydrogen above the plane or both hydrogen behind the plane. This is what is the concerted mechanism. Very similar in syn addition, you have come across osmium tetroxide. Once add, it has two surfaces. This olefin has one is above the plane and that is behind the plane. So both OH can be added. It is always a syn addition. So, or you can say the concerted mechanism involving. So both OH shall be adding above the plane or both shall be adding behind the plane. So this is the what I have presented. Both OHs are above the plane or both hydroxyls behind the plane. If you remember, first osmate shall form, then osmate shall be oxidized with NMPO to result in the elimination of osmium tetroxide back, resulting in the formation of these two entities. You see, two new asymmetric centers are generated. So there are four asymmetric centers possible. You have come across in previous class, the number of isomers is formula is 2 to raise power n. N is the number of asymmetric centers. So here there are two asymmetric center new generated. So 2 to raise power 2 means 4 isomers are possible. So here 2 isomers has been produced, rather 4 isomers. So in this case, that's why we can call this a reaction. This is in fact in the end of this course, I shall present you some stereochemical aspects that we very widely use here. What is regioselectivity, stereoselectivity, and the stereospecificity. First, you need to learn some reactions. In this case, you see out of 4, only 2 isomers are forming. So if this is forming, but unfortunately, both of these have equal opportunity. So if this is formed, let's say 1 gram, it shall also be formed 1 gram. So both are isomers. So they both of them shall be resulted in equal ratio. This is we call stereospecificity. That out of 4 isomers are possible, but 2 of them are forming only. Other 2 are not forming at all. This is what we call is the stereo specificity. And stereoselectivity is one in which the products which are formed, stereoisomer form, they should be formed in unequal ratio. For example, if this is, let's say 51%, this is 49%, this is a variation. So they are not exactly the same, so it shall be stereo selective. But no, both are forming in equal ratio, so that's why there is no stereo selectivity. But 2 of them are forming out of 4, so this is a stereo specificity. This is called stereo specific reaction. Now look at the other one. You have already come across, you have seen the mechanism with MCPBI. It is a anti-addition. Just to show you again, uh, this is the MCPB addition. You have already come across. If you are starting with a trans olefin, you have seen you always end with a erythro entity. But if you start with a cis olefin, anti-addition shall always give you 3 O product. This is what I have presented earlier. So here you see these 2 products. These are erythro. Cis olefin, syn addition, resulting a syn product. So this is what you have already come across in MC, this osmium tetroxide. a transolefin, syn addition, giving you trio. What if it is opposite? If you have a syn addition, you shall get a trio entity, erythro entity. This is what you have already come across. This is, I going to summarize this what you have learned here in previous week. So if it is MCPBA, cis-olefin, anti-addition shall result trio. These two products are trio. You see, both of these two isomers are having opposite relationship because you have seen the mechanism. One OH, one oxygen adds in the first step. The second oxygen adds in the second step. So this is, and both oxygen which are adding are opposite to each other, 180 degree. This is what we call anti-addition. You have learned it always takes place in more than one number of steps. So it is resulting a syn addition, same substrate. MCPBA is resulting a anti-addition, resulting a entirely different stereoisomers. Now you see, these are the two isomers possible. They are not, they are forming in this one, and these two are also possible isomers. They are not forming in this procedure. And similarly with MCPBA, these two isomers are forming, and there are two other isomers possible. In this case, they are not forming at all. So reaction with MCPBA or reaction with osmium tetroxide, both of these are stereospecific. In this case, both are adding opposite to cis-olefin, and here both of them are adding from the same surface. So this is resulting two different isomers in equal ratio. This is resulting two different isomer but in equal ratio. So the no doubt the reaction is stereospecific, but in both cases it is not stereoselective. Now proceeding further, bromine addition you have also come across, in which it also follow anti-addition. You have come across, this is the addition of halogens, cis-olefin. Whenever olefin, any into this cis-olefin, any halide, or you can say bromine, iodine, or chlorine, etc. adds, it always results trio products. So both isomers are formed because this can add from this surface, this can add from the other surface. This is what we have presented in one case. Right, so if let's say it is resulting two isomers in fact out of four, because four isomers are possible, only two of them are forming. So both bromine addition and MCPB addition follow anti-addition. Osmium tetroxide follows a syn addition to same olefin. Now look at, if we have HOBr, commonly called per acids, this is per bromic acid. If you have a Cl here, it is per chloric acid. If you have iodine here, it is per iodic acid. So this is per bromic acid. What we have bromine oxygen bond. Oxygen is more electronegative, bromine is less electronegative. You have seen in previous this lecture. Let's say here we have X is halogen, and this X which is leaving with the electron pair, this is OH. Oxygen more electronegative, halogen less electronegative. So this is adding, halogen is adding first, and then OH is adding later. But what shall be the fashion? Here cis-olefin anti-addition shall again result trio. One of them shall be halogen, other shall be OH. This is the only difference. I already presented, not all the time these two are equal. These may be different. So this is one example in which you have come across that both of these two are unequal. One is OH, other is Br. But whenever they shall add, they shall follow the anti-addition. Mechanism is same. Mechanism of these three mechanisms with MCPBA, with halides, and with hypohalous acids. This is same, anti-addition, resulting, you see, same isomer. This is SSRR, SSRR, SS, and RR absolute configuration. But entirely opposite isomer, two isomers, both above the plane or both behind the plane, are generated in this mechanism. So this is just a review what you have learned already. Proceeding further with a different concept, that is hydroboration. sorry, before hydroboration, let's see what is called ozonolysis. Ozonolysis is derived from ozone. What is ozone? You are already familiar with that. In the stratosphere, what we are having a 20-kilometer range from Earth crust to upward in the altitude. This is commonly called stratosphere. In the stratosphere above is mesosphere. So temperature in stratosphere is high, but in mesosphere it is decreased. Further higher it is further decreased. So 20-kilometer range from Earth crust to upward. This is in fact stratosphere. So in stratosphere we are having an ozone layer. Ozone layer is what? Molecular oxygen is present. Molecular oxygen when high frequency radiation approaches. So because if you remember, the sunlight consists of three type of radiations. When sun is producing three type of radiation, major it is 70% is IR radiation, infrared radiations, which are coming to us. It is being filtered out through ozone. It doesn't affect the ozone layer, or ozone doesn't filter this. So maximum what radiation we are observing around us are IR radiation. And what other radiation 30% are? So 21% of them are UV radiations, ultraviolet radiations, which are high frequency radiations. So in fact, ozone filters them. And third, 9% are cosmic rays. What are cosmic rays? Cosmic rays are ultra high frequency radiations, which include gamma rays, which include X rays, or vacuum ultraviolet radiations, etc. All these radiations are very less in number, and these are also being absorbed by this UV radiation. So ozone is what? Ozone is in fact allotropic form of molecular oxygen. How it happens? First of all, this molecular oxygen reacts three molecules of this in the presence of high frequency radiation like UV radiations. It converts into a three atomic system, ozone. So three molecular oxygen converts into two ozone molecules. So what is the structure of this ozone? This ozone structure I have presented here. This one. This is the structure of ozone. Ozone have, it is not a cyclic system. Long time ago, the cyclic system, three-membered ring oxygen is making is what's called ozone, but that is not the structure of ozone. Ozone structure is very similar. This is a molecular oxygen. Molecular oxygen is donating, one of them is donating electron pair to an oxygen. Oxygen, atomic oxygen, basically gaining this one. What happens? The ultraviolet, a bond between O2, one oxygen double bonded other oxygen, it breaks that bond. And what happens? Atomic oxygen generate. Atomic oxygen is reacted with molecular oxygen. We donate electron pair. This is a between this oxygen and this oxygen. This is a coordinate covalent bond. Oxygen donating and molecular oxygen donating an electron pair. So this oxygen, because gain an electron pair, it has one negative charge outside it, because this molecule has one negative, one positive charge both on this. So that's why this molecule is neutral in nature. This is what about the structure of ozone. And ozonolysis. Keeping in mind, ozone mean ozone. Lysis. Lysis is a term which is used in biochemistry to break down. Pyrolysis you have come across. Pyro means fire. Lysis means breakdown. So breakdown under the influence of fire is called pyrolysis. When we are heating any compound at very high temperature in the absence of oxygen, this is called pyrolysis, if you remember. Similarly, this is ozonolysis. Hydrolysis you have come. Hydrolysis means breakdown of water into H positive ion and hydroxyl ions. That is called hydrolysis. So this is in fact ozonolysis, mean breakdown of any entity under the influence of ozone. So whenever ozone adds, it always causes a syn addition. This is, you have seen osmium tetroxide, you have come across hydrogenation, You shall also see hydroboration in next slide, which is also a sin addition. So ozone also undergoes sin addition. How it undergoes? Let's say this is a olefin. What olefin? This is a cis olefin. So these three oxygen. So let's see, because there is a positive charge on the oxygen, this takes this electron pair off to sterilize positive charge. This oxygen becomes electron deficient, positively charged. So this olefin donates electronic density towards this. So we get a carbon oxygen bond. If we transfer this electronic density here, this carbon shall become electron deficient. As a result, this oxygen, which is electron rich, shall donate this electron pair off. So what is happening in this case? This is a concerted mechanism. This carbon oxygen bond formation and this carbon oxygen bond formation are taking place simultaneously. And this bond cleavage between oxygen oxygen and carbon carbon is taking place at the same time. So two new bond formation and two old bond, which are pi bonds in fact, is definitely called as a this is in fact very similar you have come across in the transition state. This is the characteristic. They are taking place simultaneously. Both events are taking place simultaneously. Bond dissociation and new bond formation. So what this result? It results in the formation of this entity. You see, three oxygens are in a same ring and two carbons. Now, both of these methyl shall be above the plane or both of them shall be behind the plane, because it can approach above the plane or it can approach behind the plane. I have presented it with just one, but keeping in mind another isomer is also possible. If these two groups are not equal, then it shall make a difference. Now let's see if it is both groups are equal. Now if I have this axis, let's say this is an axis, I rotate this molecule around this. Both these two groups which are above the plane shall go behind the plane. So as a result, these two isomers forming, they shall be interconvertible to each other. In fact, it shall be the same. So if these two groups attached are same, it doesn't make any difference. One isomer is formed always, but if these two are unequal, let's say one side we have methyl, other side we have ethyl, then it shall be two different isomers forming. So anyhow, I have presented because both these groups are same. These two are methyl groups. Cis butene this is. So when it is resulted, you can see both methyl are above the plane and both hydrogens are behind the plane. So this is called primary ozonite. This is a primary ozonite. This primary ozonide undergo cleavage. Why it undergo cleavage? Because if you look at here, what is important? This oxygen have two non-bonding electron pair. This oxygen have two non-bonding electron pair. This oxygen also have two non-bonding electron pair. So when two electron pair is present on each oxygen, it cause a much lone pair repulsions. If you remember, according to valence shell electron pair repulsion theory, so bond pair repulsion are the least one. Bond pair, lone pair are higher. The most steric hindrance we observe between lone pair. Here, six lone pairs are present. So they shall repel each other. As a result, this ring shall cleave. How this cleave? This is cleaving in this pattern. Let's say if I present this electron pair transfer, oxygen bond pair, not necessarily it should break. It may be this bond which may be break. So one of them is breaking in the favor of this oxygen. So this oxygen shall become electron deficient. This electron pair shall transfer between this oxygen and generate a carbon oxygen double bond, which we have presented here in black color. Other side, we are having a oxygen bond. So this carbon shall become electron deficient. So this oxygen is donating an electron pair, non-bonding electron pair here to generate this entity. This part of the molecule I have presented in blue. This